Поэтому все будет по-английски, но сначала я просто хотел узнать, кто из вас здесь, который знает, что cloud computing или ad-hoc network, в общем, знает. Но теперь я начинаю, и самое главное по-английски, это будет пригодиться потом. Теперь, reconfigurable formal models. What is the meaning of reconfigurable formal models? It is something that me and my guy actually decided to call it like this. It means something that will be changeable within the need. Why? Because I worked on format, which is ad-hoc mobile networks, and I work for the proactive routing protocols, and these things actually are based on the need. I chose to work on based on the need, so that's why it is reconfigurable. And cloud computing, everybody knows what is the cloud computing. I will come now and give you a small idea about what is the meaning of cloud computing. Networking and computing. Why? Because we are making formulas, which is math, and this thing will be applicable for the cloud computing. So, next. Give me next, I will skip this. Here. So, first I want to give you an idea. What is the meaning of cloud computing? Cloud computing is a term. It's a term of getting services through the internet. It means I reach any service that I need by the use of the internet. So, it is a based use on the use of the internet. So, we say based on internet. So, how the cloud computing is working? Basically, you have a cloud computing is nothing but, we call it like this, it's a cloud. Actually, it's a huge storing space. So, the cloud is nothing but, basically, a storing space, which we call CSS, we call the cloud storing system. Basically, this thing is nothing but database. And the database is depending on how you design it, how you like it to be. It's like, it's a very, very huge topic, which I'm not going to talk about. Just basically, I'm giving you the fundamentals and the components of the cloud computing. So one of the things that you need to know is the existence of the database. Why? Because everything is saved in here. We're going to use this info in order to extract it and save it back. So how is this thing working? Of course, it's not only a database. It needs other things. It needs what we call the server. And there are the server of services, the server of whatever it is depending on what you need to call it. The most important thing is to know that what is the meaning of this thing and how it is like actually functioning. And what we need also, we need to be here. This is us, users. So, we are from everyone is having, for example, a mobile, or I have a PC, or I have whatever it is, like a pad, or anything that you can use the functionality of the internet through and from. You understand me? So, a pager, maybe it's a pager. Here's a pager. We're working with a code thing. Usually it's less limited, but we will need it in one way or another because we need the internet in general. So, we have here what we call it the whole atmosphere of us. So, we work based on the internet. So, we log into these things, we give data, we request also data. So, what is happening in here? The exchange will happen based on different stages, but the basic thing in here is what we are seeing in here. See, this is a basically cloud computing. This is something you will come to know. What we have something we call the TPA. It's a term, it means the third party auditor. So what is the third party auditor and how are we going to use the third party auditor thing? See, basically, what you have, data through the internet. From the very beginning, nobody cared actually about how the data has been saved or extracted or whatever. The most concern was, I need to get info. I must get my info. I need to share info with others. Then I got to do this thing. This was before the days of the internet. We send, we save, we update, we modify, we do whatever it is, we take them back. We are the clients. And at the same time, we are, in most of the terms, the authors. It means we are the owners of the data. It means sometimes we request a strange own data thing because we are not the owner of it, but we need it. And sometimes it's our own data, which we are actually trying to implement in the cloud. So, with time, there was, and till now, it's like something has appeared, and it is now our major concern. It's the major problem, which we call it the security. That's the major concern right now. See, the security is something important. Why? Because it is reflecting each and everything. Nobody wants to get some bad or corrupted or ambiguous sort of info, and it will damage your PC, it will damage your system, do whatever it is. So basically, you need to keep it safely as much as possible. So the security has come in the world of the cloud computing based on the need of the cloud computing. Saying that, see, we transfer through the internet. We faced something, we call it the third-party person. Not this third party, it's another third party. This third party is the person who is between me and between the cloud. He's trying to corrupt the data, and he's trying to get either the data will be dropped, either it will be lost, either he will use it for whatever it is, based on the need. The point is, we are against this person. We just don't need this person. We need to eliminate the effect of this person, which is a negative one, obviously. So the point is, in order for you actually think about the cloud computing, when it started like this. Then it started for something we call actually I'll start with the hierarchy. I'll start with the highest level. It is the IaaS, we call it. And then we got the PaaS. Exactly. And then and then we got the SaaS here. So what are these things? These are the major ones, which everything has started with them. It started with the major founders of the cloud, started with something they call the infrastructure. So the infrastructure, it is basically nothing but the people who has made, or nowadays they are delivering to you something called the cloud computing. It means those people, they have their own huge firm, a company. Consider this thing is nothing but Google, Yahoo, whatever. Those people, they had their own company, they had their own servers, they had their own databases. Nowadays, the term of the database for huge firms has been converted into multiple databases working together. They call it something is the data pool. Here, actually, this is another sphere. The data pool, it has like the MySQL, whatever, how programmers are doing this thing, programming this thing. But your major concern is how this thing is working in Google. Those people, they are providing their own infrastructure. They are having their own servers. They're having everything that, like, databases and whatever. And they have, the functionality, we call it, for you people to be capable of accessing. They actually manage this thing under, and they make you capable of actually reaching inside the thing. How is that even possible? See, Google people, for example, I'm giving you this. They have their own servers. Their job is to provide you here with services. Either, basically, some are free, some are with money. You see, majorly maybe free, but the major thing is the theme of pay as you go. It means you are using the info based on your need. Or let's say that you are renting. Here we can say, which is nowadays, we are renting. So the rent, it means I pay and I receive. So what those people are doing, allowing you, for example, now I'll give you a small thing. You go to Google, you go to the Gmail, then you are opening basically nothing but your data. Somebody has sent you an article. So you need what? Acrobat, Adobe, Storyboard. So you need to open this thing. So instead of not installing this thing in your PC, those people, when you go inside the Gmail, immediately he will give you the option of here, saying view. It means the Adobe thing is already on their servers, and you just need nothing to do but to access this thing. Actually, I'm just giving a general thing. I guess you know it or not, but you just understand this thing. I'm accessing, I'm getting the servers. There is no need to install this Adobe on your PC. This PC might have, Adobe might have not. So I don't need it maybe, or I need it. But if I don't, like if I'm not capable of affording it, I still can find my documents, like maybe I can review them, maybe I can download them, and all it's happening through this program. Where? This program already is in here. It's not for me. It's already for them. They provided this as like, you know, free thing for me to access to know that they are capable of. They will later on give you something called Google Tools. Some people want to make a site, some people want to make a secure site, write a database, forms, whatever. Those people, they have tools that they will give you for rent. And you will take it and you will do whatever it is with them, and you will pay as much as you go. You will get like a light bill or a water bill you get from the electricity thing. The same thing is here. So, what is the problem here? You continue with the PaaS, a platform. The platform is what I just told you right now. It's the Google tool. And you are paying for, and you are ready. So those people are telling you, you know what? If you want to make a company, we will give you like some sort of a space in our huge infrastructure. If you say no, I'm a self-dependent person, then you tell you what? Go to your firm, buy your own servers, whatever. We will give you the service, and it will be hosted by us on your infrastructure. So basically, this is what we call the platform as a service. The next one is the software as a service. It means when I go sometimes, like you go outside to any ATM machine in the bank, or you go to this place, for example, in a complex center, where you find this machine for the Kiwi wallet or whatever, you go to put money, whatever it is. It's the same thing. It's a software as a service. And the software as a service is the same as the Adobe thing, which I just pointed to. These are the three major things of using the cloud computing. So why you are actually using this cloud computing thing, and what is the third-party auditor? See, cloud computing is doing nothing but major things. Is reducing the costs of you making these things. Because you imagine, if you want to make a company before, you have to start everything from the all over, like, you do it all over again, from the very beginning till a stage. Sometimes you need to go to another place, you will even take your construction, go somewhere else. But here, no. Here you don't need to do this. Everything is rented. You finish, you go to another place, start renting again. You give a new address, and that's it. Everything will be always there. The data is there. So, reducing costs, increasing the storing space, and the flexibility. Why? The flexibility is what I just told you right now. I don't need to start always construction from all over again. The construction of mine will always be there, and I will be just updating. Here, see, this is the client's environment, and he's the CSS. This is basically what I just told you, here and here. Before, when the security people had this problem here, something has appeared. It's called the third-party auditor. There were models. Now we are discussing. These models are basically on something we call the public verifiability. Why? Because you have basically two kinds of cloud computing. You have private, and we say public, or we can say common, whatever. But I prefer to be like this. And public cloud. In order to check the data, see, private cloud, it means all this team, usually it's applicable, for example, for this. A person at home with his own infrastructure, he wants to check the security. I cannot, for example, let Osman go inside my PC unless he will authenticate who is he. He's having IDs, he's having passwords, he's having like sometimes fingerprints, whatever. It depends on the technology that you are using. So private cloud, to do the auditing for it, it's a little bit easy. Not that much of a challenge. So we don't use this. Why we chose to work on this public? Because the public cloud is this cloud. It's this for everybody. So if you challenge yourself for the security of the, like, one for all, this is a big thing. Because this antivirus, firewalls, something here, small, you can actually achieve in more or less in this network, for example. But if you will work on the public, it means everybody else outside our thing. Somebody maybe I need to deliver also my services to. I want to sell them. I want to do business in this.
So you're going to use this thing in here. See, with the public, then came the public auditability. Here is the challenge, how I can authenticate and challenge the security of the data and what we call the data integrity and the data verifications, which they are happening actually here. Basically, they are happening from here till here and from here till here. Why? Because we must make sure that we are having an authenticated data. So, appeared in here, in between, to eliminate this person and kill him, like we say, this thing, TPA. Third-party auditor. So what is the meaning of the third-party auditor? Consider this as somebody between me and my friend. So see, my friend, he wants to send me information, and I must receive the information. So usually if I trust him and he trusts me, all right, we can send and receive and everything will be normal, like a send receive procedure. But what happens if he's sending me through the internet? He's not saying, we have a company, and in this company, like for example, we have intranet. It's a local network. So basically the security between us usually maintained, and the risk of losing info is less. But what is happening if he is sharing data through the internet then he will send me through the internet. And when he sends me through the internet, this is something bad, because sending and receiving needs to be authenticated. So here, this person is between me and my friend. Here is telling me that, you know what, you, my friend Smoky, send me the info. He will send the info, this guy first, he will check the packet for each and everything. Actually, this is like an algorithm thing, which I'm not going through. But he will check the message in general, the identifications, who sent, who's supposed to receive, what kind of a route, everything is authenticated. Is that really Mohi? Is that going really to Mustafa? Who's in between? Whatever. This must be authenticated. Who's doing this? This person here, the TPA, the third-party auditor. So, before, this model was not there. So the authentication was risky. I chose to work on cloud computing plus something we call the... Osman, give me the next issue. Next. What, this one? Here, I decided to work before, this is before, in my master's degree. I worked on ad hoc networks. Now, I think that I can, or still think that I can combine both of these things. This along with this. Why? Easily. You will say that, what is the ad hoc network? Everybody knows ad hoc network is something small network or big network. It is not having any infrastructure. It is based on the need, established, finished, and it doesn't have a router. It means it is depending on each and every node, a PC, a mobile network, a pad, whatever it is having its own network adapter. One is making the connection. At least you have two and more to make a connection. So, how these are connected to this? Why? Nowadays, in the world of technology, if you have a small, we say now that in our university, I have this plan in my mind, I want to apply for the university. I hope I can. But the point is, it's applicable somewhere else. That you have your own cloud computing for our university. So the students, you can actually access the cloud easily from your telephone thing. Here, what is happening? You are going through the network adapter. So basically, we are making a network, and we are capable of also exchanging data from this cloud into the small network, which is consisting of many nodes of ours. We are the ones who is making this thing. So, how is this even now possible? See, the sending and the receiving is easy. Usually, I will give you this in short. A, B, C. It means these are nodes. You look at this like this is the client, this is the cloud computing, and this is in between. Alright, this is the third-party auditor. Just a figure speech, it's not the exact one, but I'm combining for you the ideas so you understand. See, everything in the world of communication is connected and it is controlled by a time. Time to begin, time to finish. You cannot just access the whole procedure and get everything done with the exceeding of the exact limit, because this is no communication no more. So the point is, we start with the time, we end with the time. See, one thing here is mentioned threshold. Threshold, it means the time which is calculated for the route to be sent to be received. Here, as you can see, we cannot exceed these things. Here is our limit and the boundary. Data will be sent and data will be acknowledged. See, the theme is, I send, it has been acknowledged, I get back the reply, what we call it. So the point is, If you are sending nothing but packets of data. So the packets of data are traveling from one node to the other. Sometimes I gave you example of 3 nodes in here, just for you to be capable of understanding. But sometimes maybe they are 5, maybe they are 10. Nobody knows. The point is, it has been sent as a packet. See, the packet is having its own info. The head and the tail and the info and the identifiers and how it is, like, originally established and to whom it is going. All these things are inside. So basically you know this. But the more you send, actually you know one thing. There is something called the delay of the delay. What is happening? You send info, the data has been received by a node. It is not easily just going back. It's not a door. It's not a gate. It must be received. It must be processed. It must be knowing to whom you are sending and why. How is this thing B is receiving? Actually, this one is keep on forwarding. And he's waiting. Then somebody has replied. This one, I found the route. You know what? If I found the route, you do a delegation, we call it. The delegation is to give all the process of doing the things from A to B. B will be in charge now, doing everything else. Here, before I just chose one thing to work on, I modified this theme, which is the AODV. It's a routing protocol. They are in Manage. They are reactive and proactive. I chose to work with the proactive. I said this before, now I will not repeat it. See, the proactive one, I chose something called the AODV, Agile On Demand Distance Vector Routing Protocol. This thing actually was also working on 2 basic things. Acknowledgement I receive. You send, you receive. Based on, like we say, agreement with the destination that always forward package that I received. Sometimes, what is happening? This node, for one reason or another, it is like, saying it's not capable even sometimes if it is not knowing or it is not wanting, it is not capable of sending the info back. So I don't get the exact info that the route is existing or not. So we cancel this. There was another thing which they said about that. You know what? Send it with the info, if you will send back a reply, in several intervals of time, which they are not sequenced, but they are existing. For example, each and every 10 minutes, then each and every 15, whatever. Actually, this is a big thing. It's not a really thing. Each and every milliseconds, 15, 7, whatever. Send random packets along with the packet of the info, telling me that, you know what, I'm the one who is sending and this is a valid route. Also, this failed. Sometimes, for one reason or another, you are losing the data. So we came up with something we called the ACK based on the FSA. ACK is the acknowledgement theme. FSA is the finite state automation, or the automata, what they call it. For this to be accurate, finite state machine is nothing but Q0, Q1. If you got a Q0, you don't receive nothing. Actually, maybe it lost, maybe whatever has happened. If you get 1, you receive. Here we applied it easily in this thing. So we send the packet, you see, B, received, TD, TD, packet. Then at the C, which is the destination, which we need, TD, authenticated to hub acknowledgement. TD, authenticated to hub acknowledgement, I receive. Where is the TD? Time for processing, as is mentioned in here. TD is processing plus queuing. Delay at nodes B and C. Why? Because the delegation started from here and it's going all the way full here. Queuing, yes, because we have to open the packet and we know to whom it is, meant and who is supposed to receive. And these things, as a thing, it's easy for you to know this because it's a basic thing in the communication. So, I spoke about this before. I guess I don't have time to repeat it. But the point is that there was before a time has been set that I will receive. If I will not receive, kaboom. This thing is done. It's not cool. Why? Because the infrastructure is not limited. So maybe this node went out, maybe the battery of the mobile died. For one reason or another, I don't get nothing. You understand me? So the point is, we applied for one other theme. I said, you know what, let's like this, infrastructure which is not fixed, alright, but it must, at any point, have a diameter thing. See, centralization thing in here is not required. Why? Because we don't have a centralized management of the network. Because this is based, each and every node in the network is in charge for each and everyone else. It's like a router, and this one is like a router, and this one like a router. So there is no actual router. Because I just said, it is having no router. The lack of a router is routerless and the lack of the infrastructure. So maybe this infrastructure will be like this. Why? Because the nodes are moving. Anyway, I have a diameter. Before, if the time will be finished, nothing is there because the time was basically maybe the diameter. Just shortly speaking, I told you that I managed to have something for my master's degree as something new. We make the timer twice the diameter in here. So if the node maybe will go out after like 2 milliseconds, it will go back, whatever it is, I still get it back. And I'm not judging that it is false and ambiguous. And usually, I said also back, somebody told me, why we don't make it like 3 times, 4 times, 5 times the diameter of the network. I said, this is not cool. Why? Because the more you will lose time, the more you will not engineer no more. So you have to think about the cost as much as possible, like to make it less, and the time. So 2 times of the diameter, it was a little bit good, because we actually checked this for 10, for like 20, for 30 nodes, and we got good results compared with more or less time that you are actually losing in here, or the huge time you are giving. Usually it's not good, to give it all, or to give it like whatever you have, or to give it less, more than you have. Because you need to just focus on what you need, and you need to get the maximum result as much as possible. So, going back to the cloud, it's easy to know that if I will have used this, usually it's a network. It means if I have a cloud computing in here, in the university, you as a student, other students, will be capable of using this to get info from this. So if we enhance the security in here, we continue on enhancing the security in here, we should also enhance the security in here. The team was proposed by us. I was thinking that, I think that I will continue this thing to make it. See, my thing is also to add more than 1 TPA. So I will make TPA 1, maybe I have a TPA 2, or 3, That's why I said, in the before one, I said TPA 1, TPA 2, N of TPAs, based on the need. Everything is based on the need. You don't put more than it's supposed to be. Here, when those people will be working simultaneously, we will have something we call the batch auditing. Batch auditing is nothing but the delegation of the auditing tasks that will be forwarded to 1 TPA, and then if there is overhead, we say, it means a huge load in here. What will happen? You will forward the tasks simultaneously to whomever is free. So basically, in the world of cloud computing, you have nothing but something we call like, I will add it in here because you understand, clusters. So clusters, you will have this infrastructure, you will have one more PC or a server, to be honest, it's a server. You will keep it just aside. You will be, maybe you'll have like in the cluster 2 or 3 servers. You will use 2 of them, will make 1 idle, just for the sake of the backup. In the crash, you can just have a backup plan. Some people, I check that sometimes you have like center, like for example, of data in here. Those people are giving services. You might be located. See, the range of everything is depending on the internet, so it's after all, it's depending on the bandwidth and the channels. They are huge, but they will be limited in one way or another. So what we are having in here, for example, I'm here, and I'm here, other people are here, whatever it is. Due to the geographical area, we are capable of getting all the info fast enough. Consume that you are, consume the things that you are using in here. So let's say that I am here, a little bit geographically far away from the center. See, the data will be sent, and then through nodes, and through, or like we say, the intermediate stations. Data will be also forwarded to me. I have to receive it, process it, I have to pay for it, it will go back to this route. So those people in here, they say, you know what, we will do something else more efficient. Those people, Google for example, or any company with services, they will copy their services and make it like in here. So this will be an exact copy of the, like they say, the distributed systems that they have to serve you actually. So if this will be exactly here, you don't have to go all the way in here, get the info geographically, spending more time and whatever, and process it and get it. No, actually will reach this. This will save you time. That is good, right? But there was major fault of this. Why? We discovered based on our usage that actually you will not only pay money for this. You will pay money for those people for making this here. And then you will pay money for the service to be done. So actually you are paying for the people service to be copied in here. This will be charged something in dollars. Alright? And here you will also pay money, which is something in dollars. So actually you are using both in this. But what? Sometimes you risk because if you have a good business, you need something fast, you need to access, and these things are actually providing these things for you. So, in our presentation now, you will see that something is also good about this. That why we use the cloud computing in one way or another to make something. See, if I will deploy this idea in here, and if I will deploy this idea in here, of course, eventually you will need an algorithm. So, algorithms, alright, I will write in one way or another some idea of mine, and it will be programmed, and we do simulation, and we will show it like I got these results, and whatever it is. But, our goal, me and my guide in here, is he actually was this thoughtful from my guide here that he told me that, you know what, we need to make this thing, which in this work will be easily to be understood by you people, or, to be honest, by programmers. Programmers will be capable of reading this. So our idea is to develop, change this work, not to change it, but we will use something we call the Petri net. And you know, I guess, what is the meaning of this? This will allow us to do one thing. We can draw the whole formula, the whole work of us, and something that every single person will understand based on the nodes are working, and they are getting somewhere in here, and the wheel see them, and the node is moving, it is the info. Some people will participate from another thing. So, based on this, PetroNet will help us to make everything like a photo clear. Once it's clear like a photo, you can understand, everybody can understand. Then, we will come with some formulas. So the programmer he will never ever know that what you are thinking of. But once you will read the formula, he will be capable of actually doing the programming thing. So based on that, that's what we actually came up in here with. So here, what you see is we have these things. You don't need actually to know what it is. I'm just telling you that. Now, if you see this, usually you see the components of each and everything. Here are components. If we can actually gather these things and make them in the form of, mathematical formulas in here, the programmer will be easily capable of doing these things. So my job now is to think that if this will be exactly as I have in mind, then I will be continuing on this thing in here, which is the making of the TP8, like one or two more, and a system, and I will try to test it to get some results based on that. So basically, this was the whole thing. And the rest of the things that you see like in here, like formal things, because as my guy, he said that we call them formal. It's like direct executable things. And they are changeable, reconfigurable. Why? Because they are, as I told you from the very beginning, based on the need. So, formal NAM and RNAM description. This is the random and the like what we call them. See, randomly you work on things, and you do. In the world of these formulas and whatever, you have systems that you interact to directly or not. So some are deterministic and some are not, or let's say non-deterministic ones. So the NAM is this the algorithm we have, or the system of models or machines. So in here, see, formal NAM and RNAM description of the reconfigurable, deterministic or non-deterministic Turing machines are DTM and RNDTM. Basically, it will be applied for everything, but Turing machine, everybody knows how they are working. The length of info, and I will see data and data and data, and this length is having ones and zeros. Basically, actually, my guy, he asked me to, I studied these Turing machines, but I think that, older thing is to leave it behind, and new thing is to think about this, because the same basic thing is the FSA in here, which is doing everything for us. So, basically, this is the thing. I guess that now, my guy will try to show you something about this. If it is having to explain to you these things, he can explain the mathematical thing better than me. He knows about Petri nets and these things. Actually, other than this, I guess now I gave you an exact idea about that. So, till here, my job is finished. And so, Mr. Khalidi, thank you very much.